Hello everyone. So in this video, we will learn about the abstract factory pattern. We already learned about the factory pattern. So you can watch that video. Now we will learn about the abstract factory pattern. So what is it? The abstract factory pattern is a creational design pattern that lets you create an abstract representation of factories without specifying the concrete classes. So what does that mean? See, in simple words, you think of it like, factory of factories. Okay. There are several factories and then there is one factory managing it. Okay. So that factory can be used to create one common shape of factory object and then you can only implement specific methods to create those objects. So the advantage is that you retain the flexibility to define multiple concrete implementations for the factories without altering the process of using them. And also the client code is easier to change and manages a different factory at runtime. Okay. Now, what can be the possible use cases to use it? We can use it when we need a factory of related objects. Like instead of creating a factory of an object, we need to create a factory of related objects. Means what are those? Like those objects may or may not be part of an aggregation but have some sort of cohesive relationship. Like they are a part of UI, you are building some UI elements or web component like buttons or input fields or whatever. Okay. And another use case that clients will interact with the factory interface. So this means that the clients that try to use the abstract factory will only need to supply type of factory they want to use. Okay. This gives you much flexibility so that you have so many concrete implementations of different factories. You can pass any one of those inside that abstract factory so that you can build your desired object, right? Yeah, so now we will learn about how to implement this pattern. All right, so let's say we are building a rocket, right? Now, let's say that rocket has an engine with a basic engine, and it has a payload. So in that you pass the weight. Okay. You can take any other example as well, but this is the best example that I can show to you. And now there can be a stage which can have multiple engines. There can be two engines, three engines. These are the stages. Okay. And finally, you have a rocket itself, which has a payload and stages. All right. So what we are doing is we are building a rocket. It has its own engine. It will take some payload. It will have different stages, and then those will combine to build the rocket. Now, let's create an interface for the factory. Interface rocket factory. He extends rocket. This is crucial, guys. This is very crucial. T extends rocket. What we are doing, we pass this generic T. So whatever type we want to pass, whatever factory we want to pass, we can do. And then that factory will also have these properties. Okay. So here you get flexibility to use your own factory along with the core properties of a rocket. Now, it can have a create rocket method, which will return something that you are already built, okay, this T, and will create a payload, and it will also create stages, which will return the array of states. Now, we will implement our client class client. This will be used to build the rocket. This will take the rocket factor. The return type will be the type that you are passing. Now let's say rocket equals to factory dot create rocket. Okay. Think we will take okay factory. And we will now create payload. Rocket dot payload equals to factory dot create payload. So what we are doing here, to create the payload of this rocket, we are using a factory. This factory will create the payload, and this will return the payload. Now rocket dot stages factory dot create stage. All right, and then you return the rocket. This is how you are going to build your rocket. First, you are creating the rocket, which will return the type itself. After that, you create the payload and the stages. Once again, if you get confused with this type, this is just any concrete implementation that you're passing. Okay. So this is enough for the client. Now, we have a experimental rocket. This is the concrete implementation. Implement rocket. Now, let's implement this. I pressed Control plus dot. Okay. That is how it works. And we pass a color. So you can decide the color of your rocket. And now there will be a factory for this as well, a concrete implementation. Class experimental factory implements rocket factory. Now what will this take? Experimental rocket. See, what did we just do? You saw this rocket factory, T extends rocket. What is this T? This T is this experimental rocket that we are passing. So this will not only have these properties, but also the properties which are present inside the rocket. Okay. Now comes to creating the rocket. how will we create our, let's say, experimental rocket equals to new experimental rocket and we will create payload. This dot create payload and stages. All right. We will also set the color. Let's say blue and return the experimental rocket itself. Now creating the payload method that we had here, this dot create payload and this dot create stages. So now we are going to have it here. So payload simply return a JavaScript object. Weight and let's say 1500. Sorry. And the stages. So let's say stage 1 will be of type stage. This will be an object, engines, which is an array of engines, plus, let's say, 2000, plus, let's say, 2500, and we will have stage 2 as well. We copy this, stage 2, let's say 3000 and 3000. All right. Now we will return array of stages, stage 1, stage 2. Okay, all set. Now should we start using it? Before start using this, let me explain you. First, let me clear my terminal as well. All right, 1 second. What we just did, we have a concrete implementation as well. We are creating now one factory out of that abstract factory. This is the abstract factory. Okay, this is the abstract factory. Out of that, we are creating some other concrete factory implementation. So what will be this? This will be the factory of factories. That is how abstract factory pattern works. Here we implemented the interface. We have our method and you can pass literally anything. We pass this payload with weight, you can pass anything else. And we created the payload stages, we set the color. Now we will use it. Let's say const client equals to new client. So you remember this client is used to build the rocket. Now const factory equals to new experimental rocket factory and const rocket equals to client dot build rocket factory. So see guys, imagine you are just passing a factory that builds your rocket, right? I mean, to build your rocket. I mean, so you can have any other factory as well, which has different color sets and different style of making the rockets. In this way, it is giving you flexibility, create multiple implementations and making the changes easy. Now let's log it. Should we run this? I think yes. All right, it worked. See guys, we have our stages, engines, we have our color, and we have payload. Everything worked like a charm. Let's go to that again. So we have these interfaces. These do not matter much. I mean, you can create your own. And then we have a rocket. Now this is the component that you are building. You can have any other thing as well. Let's say you are creating a UI component. Let's say you are creating a header component, nav bar or sidebar or a button or whatever. Or maybe you are creating a car. Now we have a factory. This is the abstract factory. The factory of factories. You can say mother factory. Now this is the client. The client will be used to build the component variable. Okay, you're building a rocket. You might be building a UI element. You might be building a car. You might be building a cycle. So this will be used to build your component. Now there is concrete implementations of those factories. There can be hundreds. Okay, I repeat, these are the concrete implementations. These can be hundreds. You implemented first that component. After that, you created the factory out of it, which can have its own methods, but also the native methods as well. Okay, that's the whole logic of abstract factory pattern. Now you build it, you create a payload however you want. You create stages. You can even pass parameter if you want. You can add that to your interface. So yeah, and then we created a client object. So this client, what is this client? I mean, on the UI side, this client will be responsible for building and displaying the thing. Okay, what will be served to the user is uh, is the responsibility that will be handled by this client. And then this factory, experimental rocket factory, concrete implementation. Now you pass the factory as an argument, and then you see your result. This is how the abstract factory pattern works. All right, guys. I hope you were able to understand this. So now what we shall do is we will understand the disadvantages of this. What are, I mean, not really disadvantages, but we can say criticism. These are the part of interview questions. Okay. What are the disadvantages of abstract factory pattern? So disadvantages or criticism. So basically the interviewer is only asking you that when you will not use it. See, the most important thing is not when to use what, is when not to use what. Okay. So here, let's say this when you're using this pattern as with similar design patterns, this may result in unnecessary complexity and effort in the initial article. Let's say you are using this with the factory pattern. Okay. So you might end up writing more code than you ever wanted to. This will only screw up your application. Apart from that, higher levels of separation and abstraction can result more difficult systems to debug and maintain. Now, let's say you have so many implementations. The issue is coming. Let's say there is a bug. You are checking each one of those, or you are checking a single one. You found out that the issue is not there, but issue is in the mother factory. Okay. These kind of things can arise. Apart from that, It's not very obvious to start defining objects as part of a hierarchy and try to make an abstract activity without undergoing several iterations. So, I mean, you will end up refactoring your code. Okay, see, this means that since we don't really have a hierarchy here, in future changes, we are more likely to refactor our codes if changes are really, really major, which I mean can change the business logic. Okay. Now, another question is what are some real world applications of this pattern? Real world, see, you might have worked with Canvas, HTML Canvas. So there you have some elements. You are drawing a circle or you are having different shapes and all. So in order to build those components, you might use this. In this case, let's say you have built shapes like circle, square. Now these will also have their own properties like CX, CY according to the axis. Okay, X axis, Y axis. Now for these, this can have a graphics factory. Now the graphics factory you can use, and then you can use it to draw circles. Like you see here, we have a build rocket method, right, on the client side. And here we have create payload, create stages. In the same way, you can have draw circle, draw square method. Right? So yeah, this was the end of the creational design patterns, guys. Congratulations, we have finished our creational design patterns by implementing them in TypeScript. We are only seeing that a lot of people teach, these design patterns in Java or any other language, but TypeScript is also used widely nowadays, so we should know how to build scalable applications. And I'm only showing you how can you replicate those same things in TypeScript as well, so that you cannot say that it is not possible or what. Everything is possible. I mean, programming language is just a tool. You just need to use it according to your convenience. Alright, so that's enough for the day. Thanks a lot guys for watching the video. Bye.